at the Heide geothermal power plant, and while geothermal energy is a fantastic thing for Iceland, provides virtually free energy out of the heat of the earth, it's not all good news. When you start digging up all of that gas and actually, in this case, pumping it as water upwards, you actually bring with you a lot of other things. There's CO2, there's hydrogen sulfide, which is that stuff that really smells of bad eggs. It also brings up very trace minerals of things in the water itself, so arsenic and mercury amongst other things. Now those can be dealt with, they're pumped back underground with the rest of the water, but the CO2 and the hydrogen sulfide, they're both an issue because those are both greenhouse gases which need to be dealt with in one way. And what happened here at Heide is something very, very interesting. It's something called carbon capture and storage. Normal carbon capture and storage works using a chemical called an amine, and the carbon dioxide is bubbled through this liquid chemical and eventually can be stored again as a gas, but separated from everything else. What that means then is that you have to store that gas somewhere, and that's not a great idea because that gas can sometimes escape. What scientists have done here that is so pioneering is that they've actually pumped the gas underground, and the idea is that over time it will slowly get remineralized, in other words, turned into a rock itself. And that's a much safer and more secure way of storing carbon. The key to this experiment was the ground upon which this Heide plant lies. Because it's a volcanic region, a lot of this rock is basalt. And that's actually perfect for this experiment because basalt rocks contain the right minerals to turn the CO2 back into rock again. Crunch time came 2 years later when the scientists had to dig up what they'd buried. They used big drilling equipment to bring out cores of rock, and when they looked at them they found that not only some, but nearly all of the CO2 had been absorbed, had been remineralized. This has big implications elsewhere because they were just testing this here with 230 tons of CO2. The whole world produces thousands of millions of tons of CO2 each year. So technology like this could help us to find a way of dealing with that CO2 and mitigating the effects of climate change. We've been out on the Solheimjökull glacier all day, and we've been using these. These are polarized sunglasses. And you may be wondering why polarized sunglasses are supposed to be so good, but it turns out that the answer is particularly interesting when you're stood in Iceland. A long time ago, Vikings settled Iceland. And when they did, they had to cross seas that were often cloudy and almost impossible to navigate. Legends have arisen that the Vikings had something called the Sunstone, which they could hold up in the air and would tell them where the sun was, which would help them to navigate. It's thought that that sunstone was actually a material that's found here on Iceland called the calcite rock. And calcite is actually got the strange property of polarizing light. It can actually make light that's going in this direction bend one way, and light that's coming this way bend in a different way. So I have with me two polarizing filters, and each one of these will darken the light. And you can see as we go through that if I rotate this, the light doesn't actually change much from the sun behind. And that's because the light that's coming from the sun is polarized in all directions. So if we put two together, then we can allow the light to go through, or rotate one and make sure they cut out all kinds of light and they go dark.